Okay, I think I would like to go ahead and get going, and I'm sure we'll have people coming in after the start here, but they can catch up relatively easily. So, welcome to another edition of a session focused on talking about this idea of a knowledge commons, especially bridging between the Earth and environmental sciences and the space sciences as well. This is an idea that we've been exploring for the past 2 or 3 ESIP winter meetings. And I'm really excited to kind of go from this more visionary discussion to kind of getting into some of the details, helping everyone know how we can actually start building this, contributing to the resources and integrating the resources that are already available, and kind of building on past efforts and unifying them. So this session is the vision of a number of people who have been involved in these conversations over the past several years, and you'll meet and hear from each of these individuals in a moment, but I've listed them there, and this is not exhaustive. There's many other people who have contributed to these ideas. These are just people we've talked about for this session. So I do want to start with, I think these are automatically advancing, so give me 1 second to fix that. Okay. So I'm very excited to continue this discussion. I'd like to start with a land acknowledgement. I'm coming to you from the Washington, D.C. area, which is the traditional territory of the Nacotchtank, Anacostan, and Piscataway people. We acknowledge the legacy and find inspiration from this land. You can find more information at this wonderful resource, nativeland.ca. And by acknowledging territory and land, we may recognize Indigenous presence as we convene for this meeting this week. We have a responsibility to consider what it means to acknowledge the history and legacy of colonialism in our history and as a community. Throughout the discussion during this session and throughout the rest of the meeting, we note the privileges we enjoy today because of colonialism and strive to not perpetuate that future. I think being mindful that we're in the digital environment today, it's important to perhaps extend that land acknowledgement to the digital world. And this is language and learning that I received from the Data and Society group, which I've linked at the bottom. And we acknowledge the dispossession of Indigenous land by the data-driven logic of white settler expansion and uplift the sovereignty of Indigenous people and data. We commit to dismantling modern-day colonialism and its material implications in our digital worlds. Again, you can learn more at that wonderful resource there. So one thing that I think is really important to this session as we are having this open discussion about a very expansive topic, this idea of the knowledge commons, is to have a very fluid set of interactions and for people to be comfortable in this environment. And one thing that I was really inspired by from last year's winter meeting was a presentation that Emily Shaw gave about better connecting to one another and how we do that. And so she talked about this idea of introducing positionality. I think one of the ways that we kind of default to doing that in these academic settings is talking about our research, which is very valid. But it's important in creating this kind of healthy relationality to recognize that before each of us are researchers and workers, we're also individuals. So from my perspective, I just wanted to share I'm a brother, a son, a father, a recent father of a 19-month-old now. And these are things that are part of me as well, that I think it's important to share and invite everyone else to share this about themselves as well. As far as where I'm coming from in the research sector, I'm someone who has a background in space science and aerospace engineering, but been very much interested in how that bridges across domains and how we do this idea of system science. How do we integrate more information, more knowledge towards our discovery of the world around us? I've focused that on how we study the solar terrestrial system and our planetary environments. And I am very interested in connecting that to the earth sciences as well. And one of the things that's been really exciting for being involved in the ESIP community. So I want to start by introducing very briefly at a very high level this idea of the commons. And this is something that's been discussed for many centuries in our history. It's any resource that's owned, used, and managed by a community. But it's important to recognize this is also a social regime for managing a collectively owned resource. The traditional area for studying the commons has been natural resources. So oceans, atmosphere, more recently Antarctica and space. So how do we govern and allow to flourish these spaces that we share in common together? More recently, this idea of the commons has been studied both from the sociological perspective and then bringing it into our modern day, where how we share knowledge in our digital spaces is very much a topic that we need to be thinking about. And I think it's very much the focus of this session as well. The commons in this situation is the same. It's a social regime that's for managing a collectively owned resource. And so as we try to understand how we manage our knowledge and our digital commons, these areas and these principles that we've learned in managing natural resource commons are extremely important and can be adapted over. So I'm pointing here to Elinor Ostrom's Nobel laureate work called Governing the Commons. For the longest time, it was thought that any common space was doomed to this idea, this kind of, that was very, very popular, called the tragedy of the commons, that overuse would just deplete the resource and it would collapse. Elinor Ostrom kind of debunked that myth in studying a number of common situations, actual use cases where common spaces were flourishing and the communities around them were flourishing. She actually wrote these 8 design principles for common spaces. And I think one of the things that's extremely exciting to me is how do we adapt those design principles over to the knowledge common spaces? How do we transfer over that learning to help us understand how we interact over our knowledge and create these platforms that we can collaborate around together? So I would point people to these 2 works by Elinor Ostrom and Charlotte Hess they're absolutely fantastic and surprisingly rarely cited or not as well known, I think, in some of our circles. So I wanted to bring those here. But I thought in bringing this to the ESIP context and kind of setting the stage for today, I would try to do something that puts in perspective the evolution of our community towards the knowledge commons. So addressing the socio-technical needs of cross-disciplinary communities. And so I want to chart that evolution at ESIP, and this will be kind of high level. And of course, there are many more activities we could speak about, but just in the sake of time, we'll focus on a few. So there was a session that many of our co-conveners were involved in facilitating back in 2020. And their purpose was to build a vision for how to federate the diverse ESIP activities handling knowledge, digitization, and representation. And so they were really focused on building semantic resources that would bring together the information and data within ESIP. That session was called the Visioning and Operational Grade Digital Knowledge Commons for Earth and Environmental Science. You can watch the recording and read the notes at the link at the bottom. And that led to some very important movements that have been ongoing in ESIP since then. So one of which is this kindred idea of the Federation of Semantic Resources for Earth and Environmental Science, or SERENE. And then also a set of curated semantic resources that are managed by this community ontology repository within ESIP itself. These are important efforts that we need to use as a foundation for the work that we're talking about today. And I wanted to make sure everyone was aware of that. Beyond that, in 2021, we started to think about how we expand this idea of knowledge commons to the sciences as well. So we held a session that wasn't necessarily talking about the knowledge commons per se yet. It was really focused on this knowledge infrastructure, the semantic technology component of it, where we were trying to create knowledge graphs and networks for the Earth and space sciences. And what we wanted to do there was to highlight the home run stories, kind of the things that really we pointed to as being successes in doing this and creating these and giving people kind of these examples that they could then move their own work towards. So the outcomes from that session were outstanding. We had a lot of participants. We engaged a lot of new communities. It turned out that a lot of people outside of the immediate ESIP community at that time were very interested in this. And we were able to highlight a number of home run stories for knowledge graphs. And in so doing, we identified a couple of important dimensions. So we broadened the scope of the knowledge graph. We defined this new role, which was the knowledge scientist, which had additional literacies from the normal scientist role that we have now. And then we formed smaller working groups to start building out these knowledge graphs that continue to this day. Then in 2022, last year, we held another session, which was trying to move from knowledge graphs and knowledge networks up towards knowledge communities. The people that are part of this session today were also a part of that session. And so they were going to be continuing on those ideas today. And this was trying to move towards a knowledge commons, so from the knowledge graphs and networks. And this cut across many different groups that were passionate about this, and we're doing active work on this. So a couple of the outcomes from that event that lead into today: we expanded participation during that event. We published 9 essays. We have a space that remains open on the PubPub platform called the Space Collection, that are a repository of resources for each of you to compile notes, useful data sets, essays that you may want to write, long or short form, however, whatever format you want to put that in, to put that online and create conversation around them. And then we broadened the reach of what we were trying to do across ESIP. So engaging several different ESIP working groups that I think you'll look across the participants today and recognize the connections there. And we started to understand what elements do we need to add to this knowledge graph and network discussion, the knowledge infrastructure, to get to something like a knowledge commons. And so that kind of brings us here today, what we're trying to do, which is understand that we still don't understand the full extent of a commons, and we're still kind of waiting to unify a lot of these excellent efforts and actually create a knowledge commons. So what we're here to do today is to help you understand, get more granularity on what a commons is, and actually start integrating and start participating in creation of these, bringing in the work that you're already doing and trying to converge each of these towards something that we can start to build out. So what we're going to do today is try to identify first the dimensions of the knowledge commons that we're talking about that help you understand where your work fits in, and then think about at the broader ESIP level to understand how these pieces fit together. So I like to share just this high level conceptualization of a knowledge commons that we wrote about after that first winter meeting. And I think it still is relevant today. And of course, this is an evolving conversation. But a knowledge commons is a combination of intelligent information representation, open governance and trust required to create a participatory ecosystem where the whole community is responsible for maintaining and evolving the information space. I know that's a mouthful, so I want to kind of chunk this up just a little bit, which is what we're going to focus today's discussion on. So the first dimension of this is intelligent information representation. So this is where the roles of things like ESIP Semantic Technology Working Group are really helping build out. Then there's the openness, governance, and trust aspect, which I think are terms that you're hearing more and more across the ESIP community and becoming extremely important. And then finally, this idea of creating a participatory ecosystem. So it's not just creating an excellent resource, but it's giving thought to how individuals, communities, groups use those resources. So designing the platform, designing the accessibility and usability. These are the three dimensions that we've kind of identified for Knowledge Commons, and we'll be talking about at the beginning of today's discussion. So a quick look before we jump into the agenda is how we're going to do today. So we're going to begin at the general level, discussing the Knowledge Commons, hearing from thought leaders across each of these dimensions we've just discussed, and have a panel discussion that looks at what the work within those dimensions looks like. Then we're going to help give it more granularity. We're going to go from the general to the specific, and we're going to present how space science and heliophysics is a new use case that can be added to the environmental and earth sciences and be something that's really tangible to help us kind of build out some of this infrastructure that we haven't yet done. And then finally, we're going to go into breakout rooms where we're going to hear from each of you about the questions you have, how you can contribute and respond to those questions, and so that we all come away with a better understanding of a knowledge commons and can be aligning our work towards that. So I just want to mention it won't end, obviously, with this 90-minute session. There's fantastic sessions across the rest of the ESIP week that I hope you will join. And then I also invite everyone to take a look at our PubPub Space Collection page and publish what you're thinking and writing about there. Make it more visible. And think in public together about those things. And then finally, there's a lot going on beyond this week in the immediate term. So we want to invite you to help us brainstorm how we interact moving forward. So please feel free to share your notes in the chat, reach out to specific individuals. I'm really hopeful that people will connect with one another and try to create in kind of this heat of the first emotion of this session. So as you're being inspired by what you hear, reach out to people and start to try and create something as you're listening, and not try and just maybe write a to-do note for later, but try and act now on some of these things. There's someone who I really admire, Cesar Hidalgo, is a researcher, and he writes, act on first emotion. Don't lose the emotional energy that comes with creativity. And so that's kind of the charge I will give to you for today. So just kind of framing what we think success looks like for this, we want to create a shared understanding of these different dimensions of a knowledge commons so that you can leave with that and understand where your work fits in. We want to extend and re-energize our community of practice working towards these, both from that original 2020 session and then across the past two winter meetings as well. And then we're going to offer heliophysics as a new focus for the ESIP Semantic Harmonization Group as this really tangible activity to build out the intelligent infrastructure and then to think about how do we use those. And then we also, of course, want to crystallize our discussion from these, our knowledge from these discussions. So in whatever capacity, whether it's our notes document or in the chat, or if you want to email me individually, I'm happy to help synthesize all that information so that people gain use from this session. So with that, I'm going to move into the first component of our discussion today, and that's going to be a panel. And we're extremely fortunate to have these 4 individuals join us today. I'm going to let each of them introduce themselves, so I won't say much about them other than introducing kind of the breadth of experience that they bring. So we have Ruth Dewar, who's going to be talking and kind of representing the perspective of what we know about vocabulary roundup synthesis and harmonization. Pierre Buttigieg, who's filling in for Leslie Wyborn, and thanks, Pierre, for doing that on short notice. His perspective is going to be understanding the interconnections between knowledge infrastructure and the other elements that we've talked about for Knowledge Commons. Then we're very fortunate to have 2 individuals who are kind of uncommonly capable of representing the science community and bridging between data science, knowledge infrastructure, and the science community. So Julia Stewart-Lowndes is with OpenScapes and the National Center for Ecological Analysis and Synthesis, and she's going to be representing Earth and Space Science Research Culture and Governance. And Sue Owens from the NASA Jet Propulsion Laboratory. She's going to be talking about how we bridge between data science and science communities. So with that, what I'll do is I'll invite Ruth to be the first panel member to introduce herself. We're going to have 3 minutes of opening comments from each of them, and then we're going to go into questions. I encourage people to add their thoughts, what they would like to hear from the speakers, into the chat, and we will get to as many as we can before moving on to the second and third portions of the session today. So with that, Ruth, I will share over to you, and I know that you have a couple of slides to show, so I will stop sharing my screen.
Okay, thank you very much for that introduction. And hold on just a second while I bring up a very short slideshow of exactly two slides. And now I have to figure out what you're seeing. What are you seeing?
We can see the illustration of the semantic ladder.
Okay, cool. All right. My name is Ruth Dewar, and I'm with the Ronan Institute for Independent Scholarship, but I'm also a co-chair with Gary Bergcross and some other people of the semantic harmonization cluster that ESIP has, which is one of the components of the semantic technologies committee. That committee has several subsidiary clusters underneath it, of which the harmonization cluster is one of them. And for the last couple of years, that committee has been working primarily in the cryosphere, because that's kind of where my background has been lately, to bring together a number of resources. And those resources are the 27 cryospheric glossaries that the Global Cryosphere Watch compiled, that they hired me to look at and try and figure out what to do with the suite sort of ontology set that is currently under the auspices of ESIP. ESIP is currently responsible for maintaining that. It was originally from Rob Raskin, and from almost 15, 20 years ago now. And that's now something that ESIP needs to maintain. And then in the OBO Foundry, the OBO Foundry is the biological and environmental sciences repository of semantic resources. The ENVO is the environmental ontology. So we're trying to bring all of these 3 things together. And so that's what that cluster has been doing for a while. And we're actually, the point of it was to try and come up with sort of standard ways or best practices or leading practices for doing this work. And we think done that, and we're in the midst of finalizing a paper which talks about what those sort of general harmonization processes should look like. And this is an image from that paper using the examples of those entities we're actually been working with for how to do that kind of a process. So that paper is being finalized. I was hoping to have a really solid draft before the start of this meeting, and unfortunately getting this meeting prepared slowed me down a little bit, but it's had a lot of input from a lot of people. And with that, that is kind of my intro. That's where we're at. We know how to take lots of different kinds of resources and come up with a mechanism for beginning to truly harmonize them, even though those original resources came from all sorts of different cultures, all sorts of different time periods from all over the world. But to try and begin to make some harmony out of all of that. And with that, I'll turn it over to the next speaker.
Thank you, Ruth. And I will go next to Pierre. If you want to, I don't know if you have any slides to share, but feel free to.
No, sorry, I didn't have time to create slides. It's a request, but yeah. So I'm Pierre Luigi Buttigieg. I work with the Helmholtz Metadata Collaboration. It's a partnership of all the 18 Helmholtz centers, which are everything from aerospace to earth and environment, medicine, etc. And there's a data challenge that we face to try to get the data flowing between these very different research cultures, these very different infrastructures, and also trying to bridge capacity levels. So I focus primarily on semantics, but also on digital strategy and digital architectures. So part of my time is given to the Intergovernmental Oceanographic Commission of UNESCO, where myself, Doug Fils, quite a number of others are working with global partners to build a distributed knowledge graph system using very lightweight semantics to start moving information around, and then deepening those semantics and the interoperability of the information products. So it takes a lot of technical expertise. It takes a lot of manual work to get the semantics right, to make sure that we're describing the things we think we're describing. So aligning the knowledge in order to align the information and thus help the data flow to where it is intended to flow. And then, of course, you need those layers of strategy and cultural alignments too. All of these things have to happen at the same time, and it's a process. It's a human process and a technical process. So that's primarily where I've been working. I've been contributing, of course, to the semantic harmonization work on the ENVO side in particular, and also with some of the other activities within ESIF that are, again, coming closer and closer together in this world. The knowledge graph work that Adam Shepard and others lead. That is, again, more and more it's overlapping, where we're approaching the same problem, or the same kind of basic problem from different angles. And I think we're facing that time of convergence. And it's really nice, Ryan, to hear is that next challenge of taking on the heliophysics to bring in the space crowd to the same issue. We may have different technologies and platforms at the moment, but as long as we're talking about the same problem, in a sense, as long as the problem is interoperable, the rest will follow, I'm sure, in due course. So I think that's enough. I'll keep it brief and we can have more time for the discussion.
Thanks, Pierre. Excited to have all the parts that you've been involved in helping lead involved in this session as well. I think just one thing I want to mention that's already becoming clear, and I want to make kind of explicit to the group is Ruth's talking about this harmonization process, and Pierre's talking about these different domains and bringing them together. And I think that there's a myth that we're going to have some central resource or ontology or description of our data that's going to unify all of them. The process they're describing is harmonizing across different ways of representing data. So developing crosswalks, and I think that's an important distinction, and especially in building in something like a knowledge commons, so making these things interoperable. So I will jump next to Julia. Julia, are you ready?
Hi, yes, I am. It's great to be here. Thanks so much for having this session and for inviting me to share. I am going to just screen share a few slides and actually just reuse these slides from a talk at AGU. So in the spirit of open science, reusing is a big part of that. So I'm Julia Stewart-Lowndes. I am founding director of OpenScapes and collaborate with Aaron Robinson on the OpenScapes project, and particularly with our work with NASA. And our whole OpenScapes community is people who are often researchers, learners, and mentors practicing open science in their daily work as they work with data-intensive workflows, migrate to the cloud, learn how to collaborate, and really harness the power of data science and open science and the tools and practices that exist. So what we do is we think of open science and this whole landscape of data and community and code and semantics and knowledge commons. We think of it as this beautiful landscape with many existing paths forward, like you see in kind of the background main part of this image. And what we do is we help researchers who can feel sort of lonely and isolated, like the animals in the bottom left foreground here. We help them kind of come together and find their trailhead together and see this landscape that might have been out of view in the past. And so what we really focus on is really welcoming folks to participate in this ongoing amazing work and help them navigate these paths safely together with their teams and also contribute to these building new paths forward. So I think a lot of this is about really establishing, I love, this idea of commons is so exciting to talk about here. We're really trying to establish this mindset around future us. The idea that we're not alone in science, the things that we do on a daily level can support not only ourselves in the future, but team members that might join a project, people that might receive a project if it's handed off, or strangers across the internet who can become colleagues or like leverage and work with resources that are contributed through open science. And so a lot of this though, so we kind of blend tech, like I said, cloud and coding and digital infrastructure with that human side and really the mindsets that we have to overcome, particularly around science that have been very individual, very competitive, very sort of the hero model of science. So really trying to welcome that idea of sharing and collaboration and create places where collaboration can thrive. So I, just to keep things short, I'm not going to say everything on this slide here, but really this idea of this future us mindset and empowering and amplifying open leaders. This is about creating these like psychologically safe spaces, places to create shared documentation that welcome more folks, and really to invest in leaders and leadership skills as well as technology skills. And one place just to end here is our work with NASA OpenScapes, which is a 3-year ongoing activity to really develop and support a community of mentors across the NASA data centers. And I think what's really cool about this illustration is from Alexis Hunzinger, who I believe is here in our session here, from one of her posters at AGU, where this illustration really on the left here shows like movement building in action, where you take the NASA OpenScapes mentors community, which is the smaller community, that then can bring practices back to data centers, support end user researchers, and really contribute back and be supported by the open science community. So that's a way that we think about knowledge commons. So I will stop sharing. Thanks so much.
Thank you so much, Julia. And Sue, I will hand it over to you.
Okay, thank you. I don't have slides. I thought I would just give my introduction verbally, but thank you very much for inviting me. I'm really excited to be part of this conversation. So my name is Susan Owen. I am here at Jet Propulsion Labs, and I am the Earth Science Section Manager here at JPL. So the person who's kind of overseeing or manager for about 140, 150 Earth scientists, ranging from ocean science to cryosphere to ecosystems to solid Earth and a couple of areas in between. I'm also serving on the NISAR mission, an Earth observing satellite that's going to be providing a lot of data once it launches in 2024, using radar to study how the Earth is changing. But I'm actually here in my third hat, wearing my third hat, which is co-lead for an initiative that we call SUDS. SUDS stands for Scientific Understanding from Data Science. And this is a project that started a couple of years ago. We started out with my co-lead, Lucas Mandrake. We had a charter to try and understand the landscape of how data science was being used to understand physical processes, physical science processes within the research community at JPL. And that was the research community that includes not only earth science, but also astrophysics and planetary. And data science refers to, how we're using machine learning, how we're using uncertainty quantification, and how we're using model-based inference. So really trying to understand what the current state of the practice is, where the challenges are. We saw a lot of opportunity with the work that we do here at JPL in trying to get better. We had a sense already going into this that we needed to facilitate a stronger community of practice between the experts that we had in the data science, it's in a different organization, and the experts that we had working with physical science data, which is in the science division. So what we had a year-long study to identify kind of what some of the challenges were to this and to brainstorm and consolidate ideas on recommendations for how we can have a cultural change so that it is, so we can facilitate and kind of accelerate the infusion of the advances that we're seeing in data science into the physical science research community at JPL. And we've been in this project for about a year now in terms of the implementation, about a year and a half. I'm really curious about some of the things I'm hearing about the Knowledge Commons. The way that we've been approaching it has been more people and culture focused. So we have been implementing training sessions that help build intuition between the physical science and the data science. We've been working on demonstrating examples. Physical scientists get really excited when they see other people doing really impactful science using certain tools. That's a great way to kind of show to the data science, to the physical science community, how valuable and these things can be done, and to maybe erase some of the skepticism or mitigate that. And also one of the things that we've been that was most recently done that was really exciting was to have a workshop that was also kind of a brainstorming session. So having co-creation opportunities that were somewhat structured so that the data science and the physical scientists could work together to come up with concepts of research activities that require both to really advance. And so, these are the ways that we're trying to break down the barriers between the different communities and change the culture that we currently see on lab. Anyway, that's my introduction and a little bit of background on SUDS.
Thank you. Thank you to all four panelists. I know that there are going to be a lot of questions that we're not going to be able to get to in this short panel session, but I do encourage people. And one of the reasons for having each of these people join us today was that you could be introduced to them and their efforts and connect with them better. So I want to kind of maybe start with something you mentioned, Sue, which is kind of broadening the definition of data science. I think in ESIP, we kind of have this assumption that everyone has this broader definition, but I want to make it explicit. This is how we think about data science in this session. It's not just machine learning. It encompasses machine learning, but it's much broader than that. It's everything from the collection of data to the management to the analysis, which is a small component of that might be machine learning, to the communication and the visualization of those data. All of those pertain to what we're talking about with the Knowledge Commons. When we create all these research artifacts that have to be tracked and shared and understood, it's very important to understand how we describe those so that others can understand them and pick them up and actually be able to access and use them. So I want to start with this first dimension of the Knowledge Commons, which is the actual intelligent infrastructure itself. How do we make those relationships explicit between our data so that they can be integrated? And there's been some excellent chat in the Q&A about this glossary harmonization process that has been undertaken and really very successfully demonstrated within the cryoSPHERE community. Ruth, could you say a few words, and maybe Pierre, you could add your thoughts too about what this harmonization process looks like, and then kind of bridging over into how people use those resources. How has that process been made understandable by cryoSPHERE scientists, for instance?
Okay, so I think most scientists are aware of the issues that they have with their own terminology, in that, things like sea surface temperature. What does that really mean? Was it done with a bucket? How many feet under the water? Was it measured 8 feet above the water? Using what? And that's what the cryospheric compilation of 27 vocabularies was all about, is getting all those terms and finding out what everybody's definition of the word glacier or thermokarst or any of the terms commonly used by the science community, what those terms really meant, and analyzing them to see where are the differences, where are the similarities. Oh, this term is used 20 different ways. And then actually taking the effort, in SWEET and primarily ENBO, which is where the bulk of the work was done, to then codify those in a human and machine understandable way by adding the axioms that says, okay, this kind of a sea surface temperature was taken using this kind of a bucket and under the water that way. Well, actually, let me just use some cryospheric ones. I was only using the sea surface temperature one because that's the one everybody always talked about for AGU for like 10 or 15 years. It was just totally crazy. But for example, codifying, what is a glacier? What is an iceberg? It's something that came from ice that was formed on land. It's not ice that was formed from ocean water, but land surface water, that kind of thing. And formally encoding that so that when you're actually using those terms, the computer can understand what you really mean and make inferences. Like, what is first year sea ice? It has times, and it's more saline than older ice, etc. That kind of thing, encoding that. And what was the rest of the question?
Well, Ruth, that's actually a perfect point. There are many scientists that we need to be participating in these activities in describing data that aren't familiar with semantics. They don't know how to create an ontology. They don't know those languages, those programming languages. How do you invite them and make it easy for them to be involved in that process?
Well, the easiest way is actually join the cluster and join us. If you care about cryospheric things and cryospheric terminology, or you're a hydrologist and you would like to include glacier meltwater in your modeling, join us and help create the definitions that you need to do your work. I mean, that's kind of what ESIP's all about, actually. Other than that, you just have to pay attention to, and I think a lot of scientists do this naturally, to perhaps not deliberately, to understanding that if they're talking to another scientist, maybe from another part of the world, and using the same term, you have to be careful that you actually know what the word they're using means to them. And that's where being aware of what these things are is important. And understanding that you don't have to argue about, oh, thermokarst, is it a process or a landform? That you can have a thermokarst process and a thermokarst landform as two separate things, and that's okay. And that it's okay for there to be an Australian definition of the word blizzard and a United States definition of the word blizzard from their disparate weather services. And just understanding that the computer knows that there are things called blizzards and that they come in kinds. Some of them are Australian and some of them are US, etc. And that's okay.
Thank you, Ruth. I want to turn to Julia and Sue, who both represent, working with scientists. And Julia, you alluded to this. that there might be new literacies or capacities that are required to do open science and certainly to contribute to the knowledge commons. So how would you both begin to describe the literacies that you see as being kind of things that scientists need to be thinking about?
I'm happy to kick it off and then pass over to you, Susan. So I'm a marine ecologist by background. So environmental science is where I'm sort of starting from. And in our formal education, it's very uncommon to have any kind of computing skills formally taught. That's changing. People are learning R and Python through their ecology classes, depending on the teachers. But we also find that oftentimes like upcoming and tenured faculty don't feel confident teaching coding skills, even if they themselves are coders, because they feel like since they weren't formally taught, they're not experts. So I think coding and computing literacy and around data workflows, collaboration, and then emerging collaborative tools and established collaborative tools like GitHub and Cloud are big places for literacy with researchers. And I'd say too, like something I've learned a lot is to not assume that folks in technical fields have access and support to developing technical skills. I think that there's, I've worked also with folks in biomed and earth science, and sort of assuming that they must know Python already is something that like asking questions rather than assuming, and it's been a big part of our work. I'd also just say, and I mentioned like collaboration and that kind of individual hero mindset of science and kind of overcoming that. And one of the ways we work is really thinking about helping scientists see themselves as part of a team, whether that's within their academic lab group, whether that's within their government division or center, and then beyond there, like across labs or in your academic department or across centers within your government institution. And that's a really amazing place to work, to build that kind of trust. So you're working openly within that kind of team, even if open is not public. And that also gets into kind of ideas of governance and just within a lab group. Like, do we have a Google Drive where we share slides so everybody's not like creating the same slides to introduce our lab's work to begin with, that kind of thing. And so there's like this sort of trust building and governance and literacy that can happen, within these smaller team scales too, which is really great.
Yeah, I'll just say, I think Julia mentioned a lot of the literacies that I think are important for the science community. And I will also just emphasize, I think, one of the things that we work on in general, I think at JPL and also as part of SUDS is getting the scientists away from that hero mindset, to make them value that it's important to understand, well, one, that there are other languages. I mean, some of the scientist's life can be very steeped in their own jargon and literacy. And then while they realize that it can be jargon to a lot of other people, there might be some lack of awareness and how deep that literacy can go and can be in computer science and data science. And so just, kind of encouraging them to view that as it's time to learn another language, and I think there is a lot of interest in open science and GitHub and in computing, and I see a lot of I see a lot of benefit for the people who have put in the effort to learn those additional languages.
Thank you both. I'm going to go to Pierre to kind of close this short panel, but I want to just kind of resonate with a few things that you were saying, in that when you start to think about getting away from this individual mindset, you start to think about other skills of the scientists that we maybe aren't as visible to us, but are very important in this. And that's, at least from my perspective, collaboration and facilitation. Ruth said, if you want scientists to participate in glossary harmonization, join the working group. The skill of that is then once they join, making it a meaningful collaboration, being able to be a facilitator of different individuals, different languages interacting with one another. So those are skills I think we need to develop, need to value more directly in how we, and as we move into the knowledge commons idea. Pierre, I know that you wanted to bring this back to intelligent infrastructure, so I'll invite you to close this panel.
Mhm. Well, hearing these views, it does come down to the, right, we've had collaboration since time immemorial in science. But it still ends up to that story where you're writing a paper, you're reading a paper, and it says, in this work, we define X as Y, right? And it's sort of limited to that chunk, that piece of work, and it's fine. It's been operational for a long time. And economically, it's been very successful. That's the economics of science. Again, part of that, just getting citations from your paper. But then what do we need in order to say, wait a second, if I say it this way, I mean it differently from another group or another discipline. We do need that infrastructure, like getting it out there on the web, getting the linked open data, having those ontologies out there to say, I mean precisely this, in a sort of immutable way that is version controlled and it changes. You know what you meant back in 2001 when you said that term. And then if that changes and communities sort of align their definitions or new official definitions come from the top down, we can trace it back to what was meant in the past. So in knowledge commons, the whole thing's going to evolve. It needs traceability, and therefore it needs infrastructure that can evolve with the shape of knowledge as more cross-disciplinary activities emerge. And I think in the semantic harmonization activities, using the kinds of tools we have used for that process, we've gone through the initial workflow. It's kind of like pioneering workflows connected to an infrastructure that can be scaled, and as you said, can be made more inclusive so that it's easier to onboard the experts, so they don't have to worry about the semantic nitty-gritty behind it. But they say, this is what we mean and this is how we mean it. It's explained, it's carried forward, and it ends up in an infrastructure that somebody, be it a machine or a human, can point to and say, when I'm moving this information or data, I'm connecting it to this understanding of the world, this knowledge representation of the world. And then once we have that, I think lots of things will be much smoother and more sustainable. Again, we should be able to analyze a data set with the understanding it had in 2001, and now the new knowledge around it in the 2020s, et cetera. So I think for all that, we need to think about what this intelligent infrastructure actually is and what its operating capacities will be.
Thank you, Pierre. Thank you, Julia. Thank you, Sue. Thank you, Ruth. I know that this was brief, but we will lead into breakouts later. And I think a lot of these discussions that we've started here will go there. And then hopefully throughout the remainder of the week, I know a number of you are leading other sessions and will be involved throughout the week. So I encourage people to continue the conversation wherever you can, in the chat for the time being, and then of course in the ESIP Slack in the longer term. But thank you each for sharing your perspective and helping seed some of these important conversations. What I want to do next is move from this general discussion around the commons. So hopefully we've developed at least a little more of a shared understanding around what those are and different dimensions of those. And so you can start to see where your work may fit into that, where you might start developing some of these literacies or bring some of these ideas into what you're doing, becoming more of an open researcher, becoming more of a knowledge commons contributor. And now I want to give you kind of more granularity in that. So we talked about how we want to make the heliophysics and space science side of things a next use case, so that as we integrate that, we start to explore some of these open questions around building knowledge commons. And so what we're going to do is we're going to hear 3 quick lightning talks. I'm going to give the first one, and I'm going to keep it very brief, about how we're kind of been doing this for heliophysics. So I'm going to share my screen, and then we'll hear from 2 other individuals who have been part of this effort as well. So I'm going to speak very quickly about just noticing that we're running a little late. So I'll try and trim some of what I'll share here and encourage you to interact with me offline. But we've been trying to do this first step, this intelligent infrastructure, and kind of the first step of intelligent infrastructure for heliophysics, building on some of the tools that are already available, in exploring this glossary harmonization process that Ruth and Pierre were alluding to for the space sciences. And one of the ways that this has been done in the past, and that I was kind of introduced to it from, is called a vocabulary camp. And this is something that's existed for a long time. We have a colleague, Gary Berg-Cross, who's been one of the pioneers and the originators of this idea. But this is kind of that venue for bringing together, gathering all of those different ways of talking about representing our data and start to understand how they connect across one another. We wanted to do this for the space sciences. And the questions that we were asking with this workshop, which consisted of knowledge scientists, ontologists, computer scientists, heliophysicists, space weather researchers across the domain and technical aspects of this, to try to create a community of practice that bridges these broad disciplines with the intent focus of trying to draft a lightweight phenomena ontology for the heliophysics domain. We wanted that to serve as a foundation not only for a knowledge graph within heliophysics, but also understanding the points where we connect to things like earth science and other domains, so we can start to build out knowledge networks. And then we want to understand, how do you sustain the development of this? So if you can write an ontology, but as Pierre described, as we all know, language evolves, the way we represent our data evolve, information and knowledge evolves. How do you sustain that over time? How do you develop rules and governance structures so that that can evolve over time and that can be maintained? That has to be done on the side of not just dedicated knowledge scientists or ontologists, but also the scientists as well. You can see a little more information about how we did it here with the link and the QR code. I encourage you to take a look there. I'm going to skip over a bit of the background, and I can go back to that later. But I did want to specifically highlight that we were focused on different intersection areas with a lot of efforts going on in this community. So how do we connect to INVO, of course, the ESIF community, and SWEET as well, which Ruth talked about a little bit. There are a lot of challenges that we recognize with this. To do this requires radically transdisciplinary collaboration. It requires developing vocabularies. And to this point, what we've seen, the pattern we see in research is that it's much easier to develop your own closed system. So anytime you have a new project, we're just going to define things this way. We're going to develop our own language. And it's much more difficult, takes much more time and resources to develop something that, or pick up something that's already existing, extend it, or be interoperable with it. And so the result has been this huge proliferation of vocabularies, leading to this necessity of glossary harmonization. Leslie has this wonderful quote that vocabularies are the Achilles heel of the FAIR principles, which are principles to help data be findable, accessible, interoperable, and reusable. Then there's the challenge of implementing semantic technologies. So to do this, we need to understand how you're implementing your semantic technologies, how you represent your data. There's a wonderful book that I'm citing here, and I think I've put it in the resources link already for you if you want to look closer at that. But how you implement these is a very open, big challenge, and I think one that we grapple with. And then there's the issue of support. So building knowledge infrastructure is a hard process. It requires new knowledges. That's hard, often underfunded, and often unrecognized work. If the infrastructure is working, you just don't recognize it. It kind of becomes invisible. And then there also needs to be granularity in the support required. That's been low to this point. It's not nearly adding more money to a project, but also including the cultural considerations of how you need to build these things out. So those are challenges we represented and we centered at this workshop. Some of the results from this: we developed a heliophysics region-based taxonomy that's going to be included in the UAT at the end. We included a portion of this at the end of last year, and we're going to be continuing to provide these as updates. Now, this is something we want to develop into a formal ontology, but it's an excellent starting point that represents a lot of the culmination of a lot of work. And we also looked at creating a heliophysics use case. So one of the very strong, powerful areas where we can start to build out some of these things. You're going to hear in just a moment Ellie Young, who's been leading the extension of this process, conducting ethnographic interviews with heliophysicists to try and understand what the strong use cases are. And then finally, we sustained, in terms of the sustaining of this work, we developed a few different things. So there's a wonderful resource called Helionauts. This is supposed to be and is fantastic. It's a Stack Overflow-like chat space for heliophysics and space science. And this has been created through something called the Center for Helioanalytics that we've been working on for several years. And we created a dedicated space for this vocabulary camp activity that will continue to be ongoing. And then we developed a structured resources database to be a living artifact from this work and help others get acquainted with what we were doing. And then finally, we've been talking about this usability, adoption, and trust component. And you're going to hear from Donnie Winston describing that in just a moment. He'll speak to how we were able to do that. So what I'm going to do is pause there, and I'm going to hand it over to Ellie, who's going to talk about the use cases within heliophysics that we've identified.
Great, thank you, Ryan. Let me just share my screen. Okay. So what we've been doing currently is building on work that we started last year to basically build an ontology to represent community members in CFHA to help to support kind of the transaction of information about things that we typically find out through manual means only. So if someone has, a certain kind of expertise, you typically find this out by meeting them at a conference or reading a paper that they have, and sort of there's this informal network that gets developed, and you kind of use this to go through the work that you do to produce science. But this is a highly manual process, which has access challenges for people who are, not physically located together. We work in a far more remote environment now, and of course, we're interested in bias and inclusion and these kinds of issues. So what we're thinking about in approaching, sort of the open science ecosystem is what are the capacities that need to be done to produce science? We have, the production of science, which involves research and development and idea sort of generation. And then we have the production of knowledge resources, the access of knowledge resources, which is combined with the production of science. And then we have the sort of the human side, which I spotlighted, of network development. And each of these activities are sort of clustered around, the exchange of certain kinds of resources, with the user being at the center of that exchange. So to support the development of a system that might be able to not only allow us to find papers a little bit more easily, but actually to move through the entire science ecosystem, we built an ontology last year, which focuses on that user and the materials that come off of them as a unit of sort of aggregation. And so this is the ontology that we built. It's called the Cause Ontology, Community Action and Understanding via Semantic Enrichment. And it basically, it's quite straightforward. We can represent activities, affiliations like partnerships, objects, topics of expertise, and other kinds of broad categories of scientific interest. And we've also built a software interface to kind of go over this and help to support discovery. So you can see there's a variety of facets to search through, and you'll see the graph displayed, and then you can kind of click into someone's profile and find opportunities to maybe connect with them that they've offered, right? Like networking or mentorship and so on. And this is a very much a prototype that we're looking to expand this year. And so we're sort of expanding also our range of use cases, as Ryan mentioned. We've been having conversations with a variety of folks within the center, and there's a lot of challenges, not just, again, in locating the resources that we're familiar with, like papers and so on, but in exchanging any kind of information across, especially across communication lines, like between disciplines or between peoples and new groups that are not already connected, well connected. So we're seeing sort of the challenge to find scientific resources that you don't already know about. How do we find new data sets? How do we find the people that understand new data sets? How do we connect across domains? How do we find new softwares and know if this is going to be maintained and develop trust and so on? How do we also find expertise? There's a lot of sort of oral navigation, oral history at NASA, which is sort of an interesting context. And so people are, sort of dependent on their own personal networks, which are developed through meetings, to find, new things, which is a boundary, of course, to traverse for open science, which kind of revolves around people being more aware of what others are doing. So there's a variety of smaller sorts of challenges within each of these groups. So we also have, sort of more human level, human resource level challenges, like finding careers, especially for grad students who maybe don't have an advisor that's well connected, or postdocs. I talked to one person who's spending a whole lot of time on meetings to introduce his postdoc to possible future opportunities, which is obviously a very time intensive process. We talked about the option of maybe instead having a searchable database of available postdocs. So there's sort of ways that we can begin to think about how the existing approaches that we use for exchange might be supportable with software infrastructure that's connected to the knowledge infrastructure that's also being built, which is kind of where we're going with all of this. And so we're happy to hear more about your thoughts on these kinds of problems. These are sort of endemic to science. So we would like to design patterns that can work across a broad range of use cases. We'll talk about that a little bit on the breakout today, but also if you'd like to get in touch, happy to have a conversation as well. My email is here and I'm available. It's easy to find me, I think, online.
Thank you, Ellie. Donnie, I think we'll go ahead straight over to you. and you're muted at the moment.
Thank you. These are my slides. I'll go ahead and put the link in the chat. This is going to be a bit broad, but hopefully I'll at the end I'll bring it back to specifically the heliophysics centered work I've been doing with Brian and others. I was asked to talk about an overview of bringing manual and automated approaches into Harmony. And I just wanted to introduce this topic a bit and explain some of the nuances and just introduce them to you very briefly to help for further discussion and provide you with some references. So manual tagging of content is absolutely necessary when people creating it, editing it, or managing it have to tag it as they upload and review it. It's also important when there's a high emphasis on quality and accuracy over necessarily quantity and speed in tagging and retrieving it. Also, there needs to be a manageable volume of added content over time, a workflow that facilitates and encourages this tagging. Particularly if there are non-text files, manual tagging for one purposes is indicated. Also, content that is varied in document types formats as well as subject areas. Also, there's lack of return on investment justification for auto tagging because it requires some investment. In terms of automated indexing, which you'll see a lot in areas outside of science, we have a very large volume of content which would require multiple human indexers and be too costly to index. Content that changes quickly, perhaps unpredictably. The need for speed in indexing, such as for time-critical information, current awareness, or news. When you have relatively standard content types with metadata, and when content's related to a relatively uniform subject area or a single industry, so there's less ambiguity of concepts. So this is where some domain specificity can help. Also, it's more naturally lended to text content only. When you're actually making controlled vocabularies along this sort of semantic spectrum, so I use taxonomy as a very broad term that could refer to controlled vocabularies, authority files, all the way up to ontologies. For manual tagging, if you want humans to actually be able to classify content, you need extensive relationships, hierarchical and associative between concepts. You need scope notes for clarification. This is part of the SCOS standard. And again, helpful for humans, you need additional common use shortcuts and phrase inversions as alternative labels. If you want to auto-categorize, the best kinds of taxonomies will have no subtle differences between concepts, particularly in the case of categorization, classification, putting things into one bucket. It's useful to have pre-coordinated concepts, but no structured subdivisions. So pre-coordinated would be, things like Dubai temperature as opposed to just temperature. And you need a greater number of alternative labels, including non-noun phrases, and you make additional use, particularly with respect to the standards of SCOS hidden labels as appropriate. Now, the same taxonomy may be used for both manual and automated tagging. This can be very useful, and this is something we've been exploring and will continue to explore, in particular with the heliophysics community and with literature sources that pertain to it. So this is often called machine-aided indexing or human in the loop. That is automated assistance to human indexers by suggesting concepts for tagging each concept item. This can raise productivity and speed while still allowing editors to make final choices to ensure accuracy, which is paramount in the sciences. However, again, this needs to put additional work into the taxonomy so that it serves both methods well. I'd like to leave you with some further reading that I found helpful. They are more general, but the Accidental Taxonomist is an excellent resource for this sort of thing, as well as human-in-the-loop machine learning. Ryan, do I have another 30 seconds or a minute, or should I?
Yeah, 30 seconds.
Okay, yeah, I just want to briefly mention that bring this down to heliophysics briefly, I have been working with Ryan on this application to query the ADS, that is the astrophysics data system, and make it a bit more amenable to heliophysics use cases. And part of that has been doing some modeling. And so this is one of the diagrams in there that just shows the idea of having items that you can evaluate. And so we set up a system that, say, has heliophysics relevant queries, and having a system whereby we can both have automated evaluating procedures, but also user evaluations to help tease out precision and recall to improve the quality of the taxonomies that we want. So just to bring it to something a bit more concrete for people. Yeah, so that's my presentation.
Thank you very much, Donnie. Thank you, Ellie. Both good windows into some of the cross-domain work we've been doing within heliophysics. Cross-domain in the sense that Donnie and Ellie are part of the knowledge science community and the computer science communities, and they've been participating in heliophysics-focused activities to try and improve how we're representing our data. So to kind of just contextualize a little bit of what Donnie was talking about, we're recognizing just the mere volume of information that needs to be represented. And it's untenable to purely manual approaches. And so we're exploring how to augment that process with some of these natural language processing approaches and representing data and automatically tagging data. So that's been very important as well. And then with the ADS, we're trying to deploy some of the semantic resources that we've been developing to really quantify how well are we representing our field, and are we improving search and discovery processes by this process. So that's the thing that we've been working on, and we encourage you to talk with us about those. What we're going to do next is take the next 15 minutes to go into breakout rooms, and I'm going to help you understand what those breakout rooms look like and help you decide where you might want to go. We've organized these around the 3 dimensions that we loosely identified earlier around the knowledge commons. The first is how to build knowledge infrastructure. So this will include things like the semantics, vocabularies, glossary harmonization. This is where you can talk about what infrastructures you rely on, what challenges you may face, and share your use cases for semantic resources. The second breakout room, we'll talk about the use of that knowledge infrastructure. So what are the characteristics of really excellent knowledge infrastructure platforms and accessing those data? What's lacking from those? And so how do we start to converge some of these automated and manual approaches for doing those? And then finally, will be the cultural dimension, which will address the sharing, governance, and trust. How do we evolve these representations over time, and how we engender trust in using them? So that is a little bit of guidance for how to join those breakout rooms. And Patty, if you're ready, I will open the breakout rooms and let people choose where they'd like to go. And we'll come back around 5:20 for short readouts on this and next steps. After the final breakout. One thing about these other workflows is it's almost difficult to experiment with those, because you need to have trust of the scientists that will use them. And if they're trying to experiment with those, they're not working as they would hope, that can take away from trust. And so that leads us into the final dimension, which is the cultural dimension of this, which was Pierre and Paco.
Yeah, sure. That's a brief readout there. We started off just saying, okay, let's define terms. We're talking about knowledge and semantics. So Kath sort of led it, say, what do you think about culture? So we sort of went from a culture as an instituted set of behaviors, where we kind of agree on a set of behaviors that gets passed down over several generations, be that human generations or working generations. And that bridges nicely to the idea of infrastructure in the first place. If we're building a commons, we're going to need not just technical infrastructure, but also social infrastructure, which sort of leads on to the ideas of culture. And Mark and others sort of elaborated on that, saying, of course, culture is much more. Those behaviors are based on shared values, shared stories, shared beliefs, and those sort of things that are more intrinsic, that motivate people to even have those behaviors or agree to adopt certain behaviors in the first place. Because we go back to the economics Kath brought up, it comes down to, like, what are you bringing into that commons, and what do you expect to take out of it? Based on that sort of economics, the values and the behaviors that are brought in there, if those are all sort of simpatico, then a culture starts to take root and develop into something productive. And that can be quite exciting. But once it's there also, and those things are laid out, then of course people need, we talked about governance, of course, that was part of the brief. governance comes from that sort of willingness to be governed in the first place. And then that's where that sort of shared cultural, let's say, identity comes into play. Without that, it'll be a little bit more of a marketplace rather than, let's say, a commons. And I think that's quite an important part, because some of the most productive, let's say, communities, they do have a agreed mode of interoperating, an agreed mode of talking to one another and handing over control to various entities at various times. The idea of shared documentation and what Julia's been speaking about, this onboarding of your future self, write this stuff as if you need to reculturalize yourself to a project, I think is again very important, because that is the legacy aspect of a lot of the work that we do here. And that's the sort of glue we need for that socio-technical story that you talked about at the beginning in the introduction, Ryan. That's the sort of glue that makes that social and technical stuff, that social and technical technology come together. We have to make sure that the literacy on the technical side is matched by the literacy on the cultural side in that developing space, and then we can be all more productive. Sort of closing on a kind of warning note, especially with the technologies we're dealing with in data and information. When you get stuff out in the wild, it's out there, right? When data is open, it's out there, and sometimes that may not work for the purposes of the original knowledge holders. And we have to be mindful of that and think very carefully about how to control that, how to allow people to control that, and also to make sure that everyone's on the same page and not caught by surprises. Paco, did you had some notes? Did you have anything to add on that?
You nailed it.
Thank you, Pierre, Paco. Thank you to all participants, facilitators, and everyone who's taken an interest in this. We're out of time today, but this obviously meeting goes on throughout the week, and I encourage people to act while they're kind of thinking about these things, while these ideas are fresh, while there's fresh emotion for this, and creativity around it. So I encourage you to reach out to individuals and start continuing these conversations. I think just in closing, I want to reiterate that the commons is a really important idea for conceptualizing many of the problems that we face today with data and information in digital spaces. And then in some ways, the challenge of our generation is to keep open the pathways to discovery of future knowledge. And so I'll leave you with that, and hope you enjoyed your first day at ESIP and look forward to talking with you throughout the week. Thank you so much.